Section 13 of Familiar Letters on Chemistry. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Larissa Jaworski, Brisbane, Australia, March 2007. Familiar Letters on Chemistry by Justus Liebig. Letter 13. My dear Sir, having in my last letter spoken of the general principles upon which the science and art of agriculture must be based, let me now direct your attention to some of those particulars between chemistry and agriculture, and demonstrate the impossibility of perfecting the important art of rearing food for man and animals without a profound knowledge of our science. All plants cultivated as food require for their healthy sustenance the alkalis and alkaline earths, each in a certain proportion, and in addition to these the cerealia do not succeed in a soil destitute of silica in a soluble condition. The combinations of this substance found as natural productions, namely the silicates, differ greatly in the degree of facility with which they undergo decomposition, in consequence of their unequal resistance opposed by their integral parts to the dissolving power of the atmospheric agencies. Thus the granite of Corsica degenerates into a powder in time which scarcely suffices to deprive the polished granite of Heidelberg of its lustre. Some soils abound in silicates, so readily decomposable that in every 1 or 2 years as much silicate of potash becomes soluble and fitted for assimilation as is required by the leaves and straw of a crop of wheat. In Hungary, extensive districts are not uncommon where wheat and tobacco have been grown alternately upon the same soil for centuries, the land never receiving back any of those mineral elements which were withdrawn in the grain and straw. On the other hand, there are fields in which the necessary amount of soluble silicate of potash for a single crop of wheat is not separated from the insoluble masses in the soil less than 2, 3, or even more years. The term fallow in agriculture designates that period in which the soil, left to the influence of the atmosphere, becomes enriched with those soluble mineral constituents. Fallow, however, does not generally imply the entire cessation of cultivation, but only an interval in the growth of the cerealia. That store of silicates and alkalis which is the principal condition of their success is obtained if potatoes or turnips are grown upon the same fields in the intermediate periods, since these crops do not abstract a particle of silica, and therefore leave the field equally fertile for the following crop of wheat. The preceding remarks will render it obvious to you that the mechanical working of the soil is the simplest and cheapest method of rendering the elements of nutrition contained in it accessible to plants. But it may be asked, are there not other means of decomposing the soil besides its mechanical subdivision? Are there not substances which, by their chemical operation, will equally well or better render its constituents suitable for entering into vegetable organisms? Yes, we certainly possess such substances, and one of them, namely quicklime, has been employed for the last century past in England for this purpose, and it would be difficult to find a substance better adapted to this service, as it is simple and in almost all localities cheap and easily accessible. In order to obtain correct views respecting the effect of quicklime upon the soil, let me remind you of the first process employed by the chemist when he is desirous of analysing a mineral, and for this purpose wishes to bring its elements into a soluble state. Let the mineral to be examined be, for instance, feldspar. This substance, taken alone, even when reduced to the finest powder, requires for its solution to be treated with an acid for weeks or months. But if we first mix it with quicklime, and expose the mixture to a moderately strong heat, the lime enters into chemical combination with certain elements of the feldspar, and its alkali, or potash, is set free. And now the acid, even without heat, dissolves not only the lime, but also so much of the silica of feldspar as to form a transparent jelly. The same effect which the lime in this process, with the aid of heat, exerts upon the feldspar, it produces when it is mixed with the alkaline argillaceous silicates, and they are for a long time kept together in a moist state. Common potter's clay or pipe clay, diffused through water and added to milk of lime, thickens immediately upon mixing, and if the mixture is kept for some months, then treated with acid, the clay becomes gelatinous, which would not occur without the admixture with the lime. The lime, in combining with the elements of the clay, liquefies it, and, what is more remarkable, liberates the greater part of its alkalis. These interesting facts were first observed by Fuchs at Munich. They have not only led to a more intimate knowledge of the nature and properties of the hydraulic cements, but, what is far more important, they explain the effects of caustic lime upon the soil, and guide the agriculturist in the application of an invaluable means of opening it, and setting free its alkalis, substances so important, nay, so indispensable to its crops. In the month of October the fields of Yorkshire and Oxfordshire look as if they were covered with snow. Whole square miles are seen whitened over with quicklime, which during the moist winter months exercises its beneficial influence upon the stiff clayey soil of those counties. According to the humus theory, quicklime ought to exert the most noxious influence upon the soil, because all organic matters contained in it are destroyed by it, and rendered incapable of yielding their humus to a new vegetation. The facts are indeed directly contrary to this now abandoned theory. The fertility of the soil is increased by the lime. The cerealia require the alkalis and alkaline silicates, which the action of the lime renders fit for assimilation by the plants. If in addition to these there is any decaying organic matter present in the soil supplying carbonic acid, it may facilitate their development, but it is not essential to their growth. If we furnish the soil with ammonia and the phosphates which are indispensable to the cerealia with the alkaline silicates, we have all the conditions necessary to ensure an abundant harvest. The atmosphere is an inexhaustible source of carbonic acid. A no less favourable influence than that of lime is exercised upon the soil of peaty land by the mere act of burning it. This greatly enhances its fertility. We have not long been acquainted with the remarkable change which the properties of clay undergo by burning. The observation was first made in the process of analysing the clay silicates. Many of these in their natural state are not acted on by acids, but they become perfectly soluble if heated to redness before the application of the acid. This property belongs to potter's clay, pipe clay, loam, and many different modifications of clay in soils. In their natural state they may be boiled in concentrated sulphuric acid, without sensible change, but if feebly burned, as is done with the pipe clay in many alum manufactories, they dissolve in the acid with the greatest facility, the contained silica being separated like jelly in a soluble state. Potter's clay belongs to the most sterile kinds of soil, and yet it contains within itself all the constituent elements essential to a most luxurious growth of plants, but their mere presence is insufficient to secure this end. The soil must be accessible to the atmosphere, to its oxygen, to its carbonic acid. They must penetrate it in order to secure the conditions necessary to a happy and vigorous development of the roots. The elements present must be brought into this particular state of combination which will enable them to enter into plants. Plastic clay is wanting in these properties, but they are imparted to it by a feeble calcination. At Hardwick Court, near Gloucester, I have seen a garden, Mr. Baker's, consisting of a stiff clay which was perfectly sterile, become by mere burning extremely fertile. The operation was extended to a depth of 3 feet. This was an expensive process, certainly, but it was effectual. The great difference in the properties of burnt and unburnt clay is illustrated by what is seen in brick houses built in moist situations. In the town of Flanders, for instance, where most buildings are brick, efflorescences of salts cover the surfaces of the walls like a white nap within a few days after they are erected. If this saline incrustation is washed away by the rain, it soon reappears, and this is even observed on walls which, like the gateway of Lisle, have been erected for centuries. These saline incrustations consist of carbonates and sulfates with alkaline bases, and it is well known that these act an important part in vegetation. The influence of lime in their production is manifested by their appearing first at the place where the mortar and brick come into contact. It will now be obvious to you that in a mixture of clay with lime, all the conditions exist for the solution of the silicated clay, and the solubility of the alkaline silicates. The lime gradually dissolving in water charged with carbonic acid acts like milk of lime upon the clay. This explains also the favourable influence which marl, by which term all those varieties of clay rich in chalk are designated, exerts upon most kinds of soil. There are marly soils which surpass all others in fertility for all kinds of plants, but I believe marl in a burnt state must be far more effective, as well as other materials possessing a similar composition, as, for instance, those species of limestone which are adapted to the preparation of hydraulic cements, for these carry to the soil not only the alkaline bases useful to plants, but also silica in a state capable of assimilation. The ashes of coals and lignite are also excellent means of ameliorating the soil, and they are used in many places for this purpose. The most suitable may be readily known by their property of forming a gelatinous mass when treated with acids, or by becoming, when mixed with cream of lime, like hydraulic cement, solid and hard as stone. I have now, I trust, explained to your satisfaction that the mechanical operations of agriculture, the application of lime and chalk to lands, and the burning of clay depend upon one and the same scientific principle. They are means of accelerating the decomposition of the alkaline clay silicates in order to provide plants at the beginning of a new vegetation with certain inorganic matters indispensable for their nutrition. End of section 13.